I thought I wouldn't bore you with a PowerPoint presentation because you've probably had a good run through from Chaz and Phil and Tim in at SA Waterhouse. So what I thought I'd do this morning is just explain a little bit about how we've come to be where we are and what we've done and where we're up to at the moment. When this project was awarded, and we did come out here at the beginning of last year, one of the first things we did, being a design and construct contract, was we spoke to Wastewater and KBR, who's doing our design, and Suez, who was doing the process design, and we put down a few ground rules. We're designing this for SA Water. It is going to be their asset. So at the end of the day, we want them to be asking us for the keys. It's their asset, they own it, so we need to be giving them what they want. So we made it clear that that's what we're doing. We're building an asset for SA Water as our customer, and ultimately Murray Bridge Council, who are the end users. The engagement process, we set about setting up workshops with the operators, with SA Water's designers, with KBR, with our proposed electrical subcontractor, with Suez as well. And we sat down and we went through the concept design that was put forward at tender, and we just went through all the options. You know, what could we do that was better? What could the operators suggest? You know, just little things like having a washdown sink up on the bioreactor, where when they take samples they can wash their hands and wash their flasks up there, rather than trying to carry dirty stuff down to the ground and wash it there. So we went through that. Electrical instrumentation, what do SA Water use? You know, what have they found they have issues with that we could look at doing better? And we come up with a list from our HAZOP and SIDS of a couple of thousand items. So from that we went through a process of what was value adding to the project, and we identified all of those first, and then we went through a review process on the commercial viability and the costs of each of those items that we thought we'd value add. And I think we narrowed that down to about 400 items that we actually implemented into the design. Once we got through that, I guess starting here on site, we started last October with the bulk earthworks. And one of the things we did, we had a heavy commitment to the industry advocate about local participation, and also with SA Water for the Indigenous component. So what we did is, with SA Water, we held some, drop-in sessions at the local shopping centre. We used social media to advertise the project, where businesses and workers could come in, fill out a form and raise expressions of interest. We also, the Narrandjeri being the traditional landowners, we had a lot of discussions with them about how we could get them involved in the project. Traditionally, you know, they end up coming on being cultural observers and standing around, you know, leaning on shovels. We wanted to do more than that. So when we spoke to Luke at the Narrandjeri, we said, look, we want to get your guys actively involved. We want to get them upskilled and provide opportunities. So we've got, at the moment, around 8 Narrandjeri who are in our work crews. They've been through work and heights training, they've obtained forklift tickets, EWP tickets, and a couple of them have gone through, I think it was their Dobman's ticket recently, Trav? Yep. So we took that on board. We thought that was very important. Also with the schools, SA Water have an active schools program, same as we do. So we went out, we had speed sessions with the school kids at Murray Bridge High School and at Unity College. We've had a couple of school kids out here on work experience as well from Unity College. So we've really tried to get the local community and the local businesses involved as much as we can. The other thing that we've done, I guess, is you'll see pump station 33, which you visited on the way in. Now that started off as just your traditional pump station, just a brick basically. So one of the things we suggested is, being an entry point to Murray Bridge, let's do something with that, landscape it. You can clad it. There's lots of things you can do to make it more attractive for the local community. And to SA Water's credit, they actually took up that initiative and they've run with it with Murray Bridge Council. And I think what we've got now is something that's going to leave a project legacy for the community. So there's going to be walking trails. There's a couple of features in there. I'm not sure if you explained about it, Chaz. You did? Yep. So I think that's important too, because a lot of times you get in these local communities and you get in, do your work, and then you disappear. We came here and we wanted to leave something for the community that was going to be of benefit to them. So I congratulate SA Water and Murray Bridge Council for actually making it happen, because typically these sorts of initiatives are very hard to get up. Where are we at the moment? So as I said, we started here last October with the bulk earthworks. We've now completed the main concrete structures and we've leak tested all of those. They've all passed without any leaks, which was, that's always a good thing to see. The structures and the tanks, I'll get Simon Coutts, who's our senior project engineer, to run through the 3D model and step us through the plant in a minute. But the structures themselves, our bioreactor is, it's about 15 metres long, 9 metres wide with 7.5 metre high walls. We elected to do those walls full height, all in one pour, internal and external, just to minimise the amount of construction joints and potential issues. We did that for our sludge tank also, the tank at pump station 34. It does take a bit more time, but we see it as a big risk reduction exercise. With the tanks being complete, we've moved on to putting all the in-ground service pipe work and conduits in here on the plant. So end of August we'll be moving into the electrical and mechanical fit-out phases. So a lot of the equipment starting to turn up on site. Moving from here back towards the existing plant, the pipeline, so there's 8 kilometres of pipeline running to the existing plant and back. Leads, we split that up into 2 packages, one from here to pump station 33 because that runs through the paddocks. Made sense to do that with a trenching machine. So we gave that to Leeds. They're doing the hydro tests at the moment. And SEM are doing the package from pump station 33 down to the existing treatment plant, because that needs to be done by conventional excavation methods. So that's where we're up to with the pipelines and the plant. Has anyone got any questions about any of that so far you'd like to ask? No?
How are you going under the highway?
We'll be directional drilling underneath the highway. So where the design started off, we were coming through the front of Unity College. I'm not sure if anyone knows the area, but there's a roundabout entrance into Unity College. We were coming through that and then coming alongside the road, Jervois Road, on the underpass, the freeway underpass. And then we came down Martin's Road, the middle of Martin's Road. One of the things we did early on, we had a look at that and we thought we'd be better served going round behind Unity College and then coming through the paddocks rather than the roadway or under the freeway. There was a lot of advantages in that from a sustainability perspective, as well as disruption and inconvenience for the local community and local residents. So what I'll do now is I'll get Simon, he'll run you through the 3D model, which has been compiled by KBR.
KBR have put this Navisworks model together for us. The actual, as I understand it, the design's been designed in a few different packages, Phil, for depending on the structural guys or the mechanical guys. Yeah, but it's all been compiled in this, which has been super handy for us as far as constructability reviews and planning the works, scheduling the works for Travis and his lads, or even just sitting down every day and just figuring out how some of these intricate structures go together. So I'm sure Tim showed you a plan early on in town, but the gist of the plant is it sits on a hill and we use gravity to flow down the hill. The pipe work comes down the driveway, which we've all driven down, and shoots into the plant around here. And we've got the incoming line coming underground here up into the inlet works. Liquid waste receival with a small pump station here for septic trucks to tip off in. The tank farm here provides all the service water, fire water and potable water for the plant. The first tank we see is the MBBR. That's the Suez provided technology. So have you got any of the little membrane balls? Yep. Wes might pass that around or talk to it later on, but this is about 60% full of Suez's, I forget what they call them, meteor membrane, yeah. Along with their aeration pipe works and blowers on the outside. The clarifier structure, I might point that out, that's a little bit more intricate. So this is what we're working through at the moment, is finishing off this clarifier. As you can see, there's a fair bit going on in here, from coagulation, flocculation, a few different flash mixers and chemical dosing, a number of intricate baffle walls which we've elected to precast some and cast in situ the others, sludge collection with their scraper arm, and then the lamella clarifier plates to drop out all the sludge into a launder channel and off to the back end of the plant. So that's sort of where our process splits up. Oops. You do need a license to drive this thing. The process sort of splits up there. We've got the treated effluent running underground through some disc filters and off into our line storages. The sludge gets extracted through here and sent through an aeration holding tank, then through some screw presses into a sludge silo and trucked out the door. We've got some alum dosing, and then that's our storages out the back. So just finished lining them. We've done the inflation test on those covers last week. Rising main pump station that sends all the treated effluent back out the door down to pump station 33 where you've just come from, which potentially, which gets boosted from there and out back to the army wetlands. A bit of UV treatment on the way out to get our one log removal. Admin building, switch room across to the side here, and the polydosing building, some sheds and some general storage areas. That's about the gist of the plant. What you'll be able to see when you get out and about is we'll take you, I imagine anyway, all things considered with the weather, down and around the ring road. So you'll see the bioreactors and the clarifier and the sludge tanks all sticking out of the ground on the right. The bulk of the mechanical plant's still yet to be installed, so Suez is starting up next month to do all their process pipe work, and then from there it really kicks off all the above ground stuff and start pulling cables and sending things into the switch room. The builders will be here next month as well to start the admin building and the switch room. Yeah, and then hopefully we'll be tidying up come October and commissioning. See how we go. Okay.
Yeah, one thing you'll find with this plant compared to most traditional wastewater treatment plants is that it is a very small footprint compared to what you're used to seeing. Now one of the reasons for that is, I'll pass some of these around. These little black things are the media that's in the bioreactor. Now you'll find there's 85,000 of those per cubic metre, and per cubic metre that covers a surface area of 4 tennis courts. Now what that does is, the increased surface area, it basically speeds up the biological process and enables the process time and the footprint required to be significantly reduced down to at least half. So yeah, that's basically it in a nutshell. I hate standing out the front talking, I feel like a lecturer. So there must be some questions from people.
With regard to the filter media, so it's obviously got that really large surface area there, just having a look at it now. I'm curious to know, how robust is it, and how long will the media last before it needs to be replaced?
The media itself in the tank, I guess from my knowledge of it, is providing it's not subject to UV direct sunlight exposure, it will last almost indefinitely. It depends on, I guess, what grit or contaminants you might have goes through the inlet works, but we do have grit washing, we do have other processes there to remove all of that. So it's really, I guess the breakdown of the media would be by abrasion and wearing. Other than that, it won't deteriorate at all. We specifically set the site up here, so I guess there is a lot of community interest in what we're doing. So we've been out to, who was it we went to that night? The Rotary Club. We've had the Scouts and a few others out here, but we set the site up so people can visit, go up to the viewing area without the need of having to dress everyone up in hard hats and PPE. So we did that for a reason, to make it more convenient for everyone.